Hi. Well done on surviving this far. As we come to the end of this two-day workshop, firstly, on behalf of the organizers, Pietro, Tianzi, and Matea, we would like to thank you. Thank you for sharing your ideas, for your intellectual openness, and for bringing energy into this conference. I must highlight that the main driver for this workshop is Tianzi, and without his persistent efforts over the last several months, we would not have convened. So please let's thank Tianzi. The breadth and interconnectivity of the research areas that we discussed or we touched upon has been quite vast. So we'd greatly appreciate any feedback you may have. Please do reach out to us if you do. There were flavors of pure mathematics, psychology, research software engineering, and drug design. So perhaps it's fair to say that the thing that did bring us together are neural networks themselves. Neural networks are fascinating objects of study, and I guess not enough can be said about the range of applications that neural networks have exposed. In particular, we are concerned here about reasoning architectures facilitated by neural networks or novel forms of reasoning. So who ordered neural networks? Does anyone care to venture a guess? So it turns out it might have been David Hilbert. So in the year 1900, David Hilbert proposed 23 problems at the International Congress of Mathematics in Paris. Of course, a bunch of them got solved immediately after, but in the 20s, he sort of comes back and discusses and reflects upon some of these questions or mathematical conjectures that he proposed. And he goes on and on about one specific conjecture, which is the 13th problem. So the 13th problem was concerned with the expression of the root of a degree 7 polynomial in a very, very specific form. So Hilbert's precise question was, given a degree 7 polynomial equation in one variable, with the current mathematical technology, it was understood that you could reduce the problem to this form. And Hilbert asked specifically, can you write down the solution x as a composition of a finite number of two-variable algebraic or continuous functions? Now, the point of making or proposing conjectures or new problems is that it can drive the development not only of the specific field in question, but one might have bonus applications. So the reason I'm talking about the 13th problem in the context of neurocomputing is this ultimately turns out to be the first guarantee for neurocomputing. So the story unfolded as follows. Soviet researchers, Kolmogorov and Arno, who were supervisor-supervisee pair, they had a friendly mathematical wager amongst themselves. Kolmogorov argued that Hilbert was correct, and Arno argued that Hilbert was incorrect. So they wrote a bunch of papers to resolve or attempt to resolve or partially resolve Hilbert's 13th problem. And they wrote an amazing representation theorem that applies to any continuous function over arbitrary number of real variables. And if you look carefully at the representation theorem, at the expression that you see on the slide, the left-hand side is a function that is a multivariate function, whereas on the right-hand side, you see a bunch of functions combined together in almost a compositional form, but each of those functions depend on one variable